So I've recently been asked, why ZFS for virtualization? I thought since I talk better than I write that I would just do a quick video on it. People who use ZFS know it's perfect. Primarily, for the simplest features, which is the pooled storage. The idea that you can have a lot of VMs running off the same pool of storage. Also snapshot and clones. The ability to take one workload and take a snapshot of it, clone it, and use that for the next workload or for the next VM. Checksumming, there's a lot of talk about deduplication and not wanting to use so many blocks, but if you're not using a lot of blocks, then you want to make sure that the blocks that are out there are valid. ZFS checksumming makes sure that when you read in data, you know that it's valid data. Also, there's a ton of redundancy out there. People are, running RAID everything. RAID 10, 20, 30, not 20, but all kinds of different RAID levels. To have that redundancy, why not have the ability to, when you have redundancy, know you have a bad block, go find a redundant copy and use the redundant copy. So checksums work perfect for virtualization. Also the log and cache, make sure that especially on the cache side, on the read cache side, you make sure that the stuff that's being used often, most frequently used, is in cache, is in memory, might be in physical RAM. If not, you can, offload some of that onto the L2 ARC or the use SSD for cache space, and you don't have to fill entire arrays full of SSD. You can use your SSD very tactically. Also, it's open source. It's available on all kinds of different platforms. And so that makes it so that it's easy to get to, very easy to use. So let me go into this a little bit more. Just a little background who I am. I'm Linda Cately. I spent 20 or more years working with Solaris. Most of that as a global Solaris expert for Sun and then Oracle. I've spent a lot of years in my career as a technology instructor. Spent some time with a ZFS-based startup, so I know some of the struggles that people might go through. Just to help you understand a little bit of ZFS and where it came from, at Sun in the mid-90s, we had hardware partitioning in our big boxes. It's very similar to what we see now with VMs, except for hardware partitions. We would have, anywhere between 5 and 10 domains per frame, big workloads running on those frames. And then in most of the customers that I had at the time, they had copies of everything everywhere. They'd have, multiple copies of the primary databases. They'd have this database, they'd have, 3 or 4 different databases, and then they'd have to have a test version, a development version, a version that went into data warehouse, all of that stuff. Snapshotting really helps with that, being able to create, I can create hundreds of snapshots of a single data set without using any disk space. Until we start to get changes. But, I can create multiple read-only copies of data. And the disk space, what happened in the mid-90s has only grown. You have, I think the number now is somewhere between 10 and 15 copies of every large database. That idea of, and we do the same thing with VMs now. VMs are so disposable that we create hundreds of them, each of them using their own quantity of disk space, and need to have rapid deployment. And then new projects always coming online. The hard part about new projects is you'd never know which one is going to be good and is going to need all the disk space or need all the system resources. How do you predict? How do you predict what needs they have? Now, when the SANs came out, the idea behind them sounded perfect, right? You have this big box, ton of disk, and you can share that disk amongst a bunch of different servers. At the time, we did have NAS, but the network bandwidth just wasn't there to really run the high-end workloads off the network bandwidth that was available. So SAN was really the only thing that gave us the latency necessary, the low latency, fiber, connected connection to the disk. And the idea was to be able to repurpose the disk easily, but the problem still was there in the file system. You still had these file systems couldn't grow or shrink, or they could. At the time, the real expensive ones could grow and shrink, but your commodity file systems couldn't just grow and shrink. You might be able to repurpose some more disk, but you couldn't get the file system to understand that. So as time went by, it used to be the disk was really cheap. The idea that the CPU was expensive and the disk was cheap kind of grew that RAID functionality in the world, where you offload those RAID calculations out to an inexpensive processor on the RAID controller. But over time, the disk architectures and disk structures got more expensive than the CPUs. So moving that RAID calculation back onto the host-based CPU, not that big a deal. And the disk controller costs. I remember looking at one of the high-end SANs, a controller for that, and it costs more than a couple new really nice cars. That idea that we offloaded that RAID calculation onto an inexpensive controller really didn't pan out. And what we were doing, we were putting all this intelligence into the SAN, and then you go into firmware upgrades, and all of them are different. You don't know, how to upgrade. With ZFS here, zpool upgrade. It's the same on Linux as it is on BSD, as it is on Solaris. We have, kind of a single structure. So the idea of ZFS is, they really looked at the problems of the day and tried to create something from scratch. The other problem too is how complicated it got. Their storage administrators ended up being kind of the highest paid people in the building, because dealing with the SANs or dealing with the storage became more and more important. Why did it get so complicated? And if you think about what you want storage to do, I want to write a file, and then someday in the future I want to read it. It really shouldn't be that complicated. And then, what was kind of the thing that we did at SAN was, look at all the problems and then solve with engineering. Look for a new engineered solution to solve for all these problems. And the biggest problem was just easily repurposing disk, just easily make the disk available to multiple workloads. That was a problem for a long time. And included in the operating system. I don't think any of the C-level people would have said this, but make it cheap and open source. I mean, the drive to make Solaris open source was huge. It was very difficult. It was a very difficult tide to stop. The culture was very open source oriented. To not open source the software would have been difficult. And then make it easy to add capacity. Even today, if you look at the large frame SAN and NAS boxes, adding capacity is not always easy. I was just looking at a thing on the web on how to add a disk to a NetApps box. 20 commands later, you might have the disk available. With ZFS, zpool add disk, and it's ready to go. So just again, to really look at one of the problems that ZFS solves is this idea of, where to put the data. That's still in the file system, no matter if it's a file system living inside a VM. All file systems are kind of stuck in this old paradigm of one file system, one disk. Even if you're using iSCSI, even if you're using SANS, you just have that one file system, one disk. And then when we moved to RAID environments, we really thought the RAID would solve the problem. We could have multiple disks, but the file system still was stuck in that, I have a single block map and this is where I write my data to. With ZFS, it keeps track of all the disks, and they have the concept of virtual devices where you have more one disk, but it keeps block maps for each of those disks so that it can make intelligent choices about where to lay the data onto the disk, so that it can write to all the disks simultaneously or read from all the disks simultaneously. The best part about ZFS is how easy it is to use, and now with OpenZFS, how cool it is that the zpool and ZFS commands work identically no matter what platform you're on. So you don't have to learn Solaris in order to have the benefits of ZFS. You can have it on your favorite Linux. You can have it on BSD. You don't have to. It'd be nice if we could see the HPUX and the AIX and some of the other ones come on board, but you have zpool and ZFS, and it's exactly the same no matter where you go. Just to show you, let me show you a VirtualBox image that I have running here on my system. I will zoom in. So I have an Open Indiana VM running here. I like Open Indiana just because it's the closest to Solaris, and since I'm a Solaris geek, that's what I use. I'm going to just start here with format just to see what the device names are of these disks, and I'll use these disks then to this 1 through 8. We can use those in our zpool. So I'm going to just do a zpool create. Now I have to name this something. I'm going to call it big pool because I call them all big pool. And then I have to say if I want to use a RAID, if I want to use a mirror or RAID Z, I identify that here. I'm going to say I'm going to create a mirror of the first 2 disks in my pool. C3, T3, D0. So I got my 2 drives, zpool create, big pool, and hit enter. Now the coolest thing, there's all these little cool things in ZFS that nobody talks about. One of my favorites is this. This automatically got mounted up on /bigpool, one command, right? That's so nice, especially if you're a system administrator. Just ease of use is so splendid here. I've got it. It's ready to go. I can use that. I can share that out. I can do whatever I want with it. The next really cool thing especially for virtualization, is adding to that pool. So I can just say zpool add to big pool. The next 2. Now I'm going to mirror these up. Now, understanding VDEVs is probably the hardest part, but once you get it, it's real easy. The idea that I'm going to mirror up the next 2 disks in my set here. I'm going to take C3 T4 D0 and C3 T5 D0, and I'm going to create a mirrored set of those 2. I'm adding this space now. I have 16 gig of space. I could have a write in flight, and df-h here, it's bigger. And I don't have to have any outage or downtime or reformat or grow or anything. It just adds. And to understand VDEVs, you can see here that it's now going to stripe across these 2 mirrored pairs. So big pool is a combination of mirror 0, which is my first VDEV, and then mirror 1. So it'll always stripe across your VDEVs, whatever VDEVs you have, virtual devices. And so it'll have a block map then of that mirrored pair. So the next step in this is just to start carving out data sets. And so use the ZFS command now to just carve out data sets, create in big pool. So I have to say, start with big pool, create a data set for VM1. And I can keep doing this. Now by default, these are all going to share the space. I can create hundreds of these data sets on top of this pool. When we do the df-h here, you can see that they're all sharing that space. In ZFS, I can use things like quotas and reservations, and they're logical components rather than physical components. You're used to physical partitions or physical LUNs. Here with the data set, it's a logical grouping of files, so I can say don't give this data set more than, I call this big pool, it's kind of tiny though, I can say, but don't give it more than 10 gig. And I can say my quota equals 10 gig. Well, let me show you how to do that. ZFS set quota equal 10 gig on big pool / VM1. And now when we do the df-h, you'll see that it's set to 10 gig. There's also reservations. There's about 40 different things that you can configure on each data set, different compression levels, different ways that you access the storage, access time turned off. So there's a number of different configurations that you can set. They are like mount options. Just think of all the different mount options you've seen in all the different file systems. So we have those same things here. Then the kind of maintenance commands for ZFS zpool status really shows you what's going on. If you're using Solaris, things like the fault manager and the service management can help solve problems that you might run into. And then the maintenance commands, zpool replace this disk with that disk, zpool offline this disk, pull it out of the chassis, put in a new one, online that disk. There's also hot spares. So the other cool feature of ZFS for virtualization is snapshots. Creating the snapshots is easy. It's a single command, ZFS create snapshot of whatever my data set name is, then the @ symbol here, and then any string I want to use to have a name for that particular snapshot. And then once I do that, it creates this .zfs directory in that VM1 data set that I can access those files. All of those files are there, the original versions of those in that directory inside of the data set. Now, all of these are read-only. Snapshots are always read-only. If you want to create a read-write version of that, I can do the ZFS clone of this snapshot, whatever I called it, and then create a new data set out of that. I can't call it VM2 because I already called that. I can call it VM5 though. And it will create a whole new data set. That big pool / VM5 now is its own data set and is read-writable. So let me just run those commands for you. So zpool snapshot, big pool, the name of the data set, and then the @ symbol, and then whatever string you want. It could be, the date, the time, the whatever you wanted to put there. And then what you'll see, so let's go in there and see that directory. Directories in Unix are not available. They're hidden. We can determine whether they're hidden or not with a variable. So now we do ls here, we can cd into snapshot, and if I had a ton of snapshots and did an ls here, you'd see, actually I have a couple of snapshots here. There's the now and the today, and if you cd in there, you'll see the whole directory structure of what existed in the original data set. So then if we want to create a read-writable version of that, we're going to just say clone whatever snapshot we were, so big pool / VM1 at today, and then we can say it does have to stay inside pool boundaries. You can't say at some other pool like our pool or whatever, but you can keep it in the same pool. And I can say at VM7. I'm going to clone that snapshot into that data set, and let me show you how that looks. Now VM7 is, here it's a regular data set that can be used like any other data set that can be shared. Now, where this becomes really powerful with virtualization is I can just use that one now, that cloned version of my original, to have multiple virtual machines. A friend of mine at Sun one time did 100, it was LDOMs at the time, but did like 100 LDOMs, created 100 LDOMs in less than a second with a little script, doing clones, and there was a little bit more plumbing involved in changing those the unique IDs on the LDOMs, but the creation time was the story. Although there are a number of other wonderful features in ZFS that are great for virtual machines, I'm just talking about a few of them. I'll just finish with this last one, which is the checksumming. Checksumming isn't anything that you turn on; it's just on by default, and it solves for data corruption. Even if you have like a multiple way mirror, and it round robins through the blocks. If you do a read and you read in a bad block, unless there's something in the application that lets you know that that's a bad block, the system may go on without ever knowing that you had bad data. In the ZFS marketing, they always talk about silent data corruption. I don't know about you, but when I have data corruption, I want it to be really noisy. I don't want silent data corruption. And that can happen with anything that doesn't have a checksum. Even if you have some of the high-end SANs or NAS boxes, they have a checksum. They have a checksum on the on the disk block itself to check if that particular disk block is bad, but they don't have anything to check for things like, is this block actually the right block for this file? Maybe there was some sort of in-flight error that happened. The controller said get block in block number 12 and you get block 13 instead. There's no way to really know that stuff. ZFS checks all the way down the chain. So it checks at the directory level, it checks at the file system level, or at the inode level, it checks at the dataset level, and it always keeps the checksum in the block pointer. So you don't keep the checksum with the data. You always have the checksum separated from where the data actually lives. So with ZFS, what it can do is that if it sees a bad block and it knows it's a bad block, if it has a redundant copy, it can go find a good copy of that data block, and then it'll replace the original, that's a bad block, we'll replace that, and you just continue on. Sometimes when people start using ZFS and they don't use the RAID capabilities of ZFS, they'll actually freak out because they'll be like, oh, I have data corruption, and the nice thing about it is that you have data corruption. It's noisy data corruption instead of silent data corruption, which may have been happening for years prior to having ZFS. You can have ZFS check your data blocks or check your file system on a regular basis, you can run the process called scrub, ZFS scrub, and it will, if you do a ZFS status, you'll be able to see how many bad blocks it found, how many checksum errors it found, where your silent data corruption had existed and is now noisy or loud data corruption in ZFS. This is very good for virtualization in particular, for just to know if there's know that it's kind of self-healing under the covers, that if it's finding bad blocks, it's correcting those, and you don't have to worry about dedupe values and whatnot to try and figure out what the accurate combination is there to good blocks and actual data protection. So I got to tell you one more thing we'll talk about. ZFS has a transactional design. It always writes into free space. It doesn't write anything to the disk until there's something to write. But because the ZFS is kind of very close to the kernel, it knows about the writes. It has some idea about the writes. It knows things like the difference between a synchronous write and asynchronous write. And it does log those transactions on a log disk. Now, it always has a ZIL. It always, writes that somewhere. But we can offload that work to faster storage like SSD. Right now, everybody's doing that, right? The hybrid storage, we're going to stage the transactions to the faster storage and then have them stage back. What we can do here is we can build hybrid storage out of commodity parts. That was kind of the coolest thing about ZFS when it first came out. You don't have to buy $1,000 drive. You can buy inexpensive drives, add a little bit of tactical SSD, and get the performance of high-end disk drives. We can do that with, this write log. We also can do that with the read cache. I hear a lot of misconceptions about the ARC. We can, ZFS will cache, and the caching algorithms are extremely elegant. If you have a chance, read up on them. Just beautifully well done. But we'll try to keep the most active data in memory, and especially for virtual machines is this powerful in the fact that if you have 100 Windows VMs running, you may be able to keep the operating system component of those in memory, and not hitting disk at any time, depending on how big your memory is. And if your memory isn't that big, you can extend the size of your memory into SSD by having the L2 ARC and putting SSD out there to having a big read cache on top of that. So you can have your active kind of working set of data, the most active stuff in memory, and then that's extended out into the read cache that you would put on SSD. Again, you can have your permanent long-term storage be the more inexpensive disks, and then keep the SSD and RAM, keeping the more active things out there. There's a lot of talk on the web, all the different discussion groups about ECC memory. Very good idea to use ECC memory. It's actually a good idea to use ECC memory anywhere where data is important. There's a lot of talk about, corrupting ZFS file systems with non-ECC memory. I mean, that can happen anywhere with any file system. The difference is with ZFS, you see that it's corrupted. With other file systems, you may not see that corruption take place. So hopefully I've gotten you excited about ZFS enough today to get you to give it a try. Pick your distro, man. There's a ton of distros out there. There's a bunch of them based on the Open Solaris or Illumos community. Just a number of them where you can use ZFS on the command line. There's a distro I'm watching, the Sonetto and the Aerostore stuff over in Europe have a GUI front end to this that's extremely modern, very robust. A lot of the enterprise versions add a cluster framework to this. Like especially the free NAS actually has True NAS, which has the kind of enterprise grade version of it. The Aerostore Sonetto stuff has a cluster on it. You also can get the cluster for any of these from the high availability guys. They have a cluster product that's just designed for ZFS. There's also a huge ZFS on Linux community. There's a very, very robust community out there. And you can take almost any distro and then add the ZFS on Linux to it. And then there's the OS Nexus guys that have a supported version of that, of ZFS on Linux. So it's nice to be able to get support if you need it, if you want to take this to a commercial application. The BSD community is quite robust. The ZFS has been in there since I think 2007. So there's, the quite robust. Most of the things have been, all the bugs have kind of shaken out of those trees. And then you can get the GUI for the free BSD on FreeNAS, freenas.org, or the NAS for free stuff. There may be more distros than this. It seems like there's more distros all the time. I try to keep up. I do the best I can. Just a quick plug for me and my company. My company is katelyco.com. Most of the business that I do is creating classes for small to medium size companies, people that don't want to hire a whole training department. My company takes on those training requests. I don't believe in week-long versions of training. Especially for senior administrators, nobody needs that. Sometimes you just need to know that one thing. So all of my classes that I offer to the general public are broken down into what I call little classlets. Most senior administrators don't have attention spans that allow them to hear things for more than a couple hours. So all my classes are 2 to 4 hours long. They're all offered live and online. The classes that I offer are all here. The Jumpstart, more detail on what we covered today. My administrative classes, all of these classes are covered on the open Solaris distros. When I get into like the admin class, I cover things like the service management framework and the fault management architecture to give you more robust fault information. Go over some of the tools and techniques for problem solving. My performance class, again, is taught on the open Solaris distros. It's kind of the low-hanging fruit with a little intro to dtrace in there. Then I have an architecture class on how to design a good system, how to design for different workloads. We talk about different workload characteristics and what kind of things that you may want to tweak with ZFS to build for those kinds of architectures. I have a deep dive on sharing. Sharing is easy. Deciding who to share to, authentication, permissions, those kinds of things gets a little bit more complicated, especially when you go into the CIF stuff and that interoperability with Active Directory. I also offer a Solaris Bootcamp or Solaris classes on demand for groups of people. I do offer the Solaris Bootcamp to the general public. It's a 4-hour class on, just getting you up to speed on Solaris. And the primary differences from other Unixes, especially Linux, the service management framework is very different. Some information on zones, dtrace, packaging, and some of the unique features, especially the network virtualization is very cool. We can take a NIC and set up bandwidth limitations on a NIC, which is pretty cool, virtual NICs. If you have any questions or comments about this, please feel free to send me email. I'd love to get email from people. I like to teach for a living, so if I left big holes in what I'm teaching you, it's nice to know what questions you still have. So you can hit me on my email or on my Skype ID. Thanks for your time.